This pretty much describes the past several, well, actually the past like year and a half for me. Just the keychain being extremely confused and having no idea what to do and how to fix some problems. And this will be a story and some information about how we managed to make that not so terrible. And we call it the Keychain Quandary Conundrum. And this is the title that you get whenever you type into ChatGPT, I want the title for a talk based on the keychain in the form of the Big Bang Theory episode titles. And I was like, oh, that's great. And then I had to look up what quandary and conundrum meant. All right, so who am I? New talk, who dis? So I am Wesley Whetstone, as we already alluded to. I currently reside in San Francisco, California. I am a client platform engineer at a payments company called Stripe. If you're not familiar with Stripe, we do online, we write a suite of products and services for taking payments and running your business on the internet. And I've been there for about 2 years, and you can find me on Slack as Wes. Now, some of you might be like, wait, Wes, you've only been at Stripe for 2 years? And I'm like, didn't you talk here several years ago and you also worked at a payments company that started with an S? I did. I worked at a payments company called Square, started with an S, ended with an E. There are current employees here. But yes, no, I am not there anymore. I am at Stripe. But if you know of a company that starts with an S, ends with an E, and has anything to do with fintech, holler at me. Just trying to check all the boxes. Yeah. Cool. So what do we got next? We're going to go over the agenda, which is always the most exciting slide. So we're going to go over the quandary that I ran into, followed by the conundrum. We're going to talk a little bit about keychain items, and then we'll actually update some keychain items. It'll be pretty fun, and then all of the roadblocks and stumbles that I ran into along the way. All right. The quandary here was a definitely somewhat unexpected journey that I found myself on, and it all started within a few months of me working at Stripe. When we got that lovely little thing from security that was like, hey, CPE, we'd love for you to do stuff for us. And that was, so to set the stage a little bit, we have identities on the Mac. We have two, one for the people and one for the endpoint. They do two different things. We had them on disk encrypted, and then we also had them in the keychain. And security was like, we don't really love the things being on disk anymore, even though they're encrypted. We would rather just chuck them in the keychain, mark them as non-exportable, and only give the things that need access to it, and don't open it wide up. And I was like, okay. And then, oh, by the way, we hired a ton of people in 2021. They all had certificates that expire in 3 years, and that's coming up in a couple of months, and it would be great if you could renew those. To which my reaction was, I was like, oh, Lord, can I go back to the last job? So back to our quandary. The big thing here was we needed to update the keychain items. And so if you're unfamiliar, you can give apps access to certain items in the keychain. And we had, when we originally provisioned the machines, we set that list of apps. And then we basically threw away the key for things that could modify it. And so we needed to find a way of how do we give the new apps that we have access to this keychain item? And the first one was well, we can just tell the apps to use the identity, and then whenever it goes to get access, it'll just prompt. That's a great idea, right? What could possibly go wrong? Except every single time you add a new app that needs access to it, you have to prompt thousands upon thousands of machines. That sounds like a great solution. So we're like, okay, that's probably not so great. The second one was well, maybe we can just spin up new identities from scratch, and we can install those, set the ACLs, call it a day. The problem was we had no way to do that. And the team that was responsible for the PKI and actually being able to get us new identities and new certs, their roadmap was even more swamped than ours. And And so over the years, I realized that people had mentioned like, oh, like if you get the password for the user, then you can probably manipulate the keychain on their behalf. And it should be like a relatively nice experience. I was like, okay, well that seems like obviously like that's the winner, right? We want to do that. So how do we do that? Like, how on earth do we capture the password and update the access? I suppose we could throw a prompt up and be like, hey, please type in your password, but that's great because teaching people to like type their password into random dialog boxes, what could possibly go wrong? And so I was like, oh, all right, well, how do we get the password in like a nice way? Like, you know, how on earth are we supposed to do that? I do have a little bit of experience writing authorized plugins. And with an authorized plugin, you can capture the password at login. And then we could use that password and like update the keychain. Sounds reasonable enough, right? But like, okay, wait, what is actually an authorized plugin? So an authorized plugin is an app bundle that you can set to run whenever you type your password at the login window. And with the bundle, you can capture the password, and then you can use it to modify the disk or like anything on the computer that'll allow you to do so. And that interaction happens between you enter your password and before you get to the desktop. So you can actually use it to like stop people from logging into the machine if you wanted. And that's the primary mechanism for it. This is kind of an abuse of its power. But authorization plugins do power several popular tools that are like out there in existence right now. Crypt is one of them, which is the one I mostly have experience with. Thanks, Graham, for starting that and getting that going. Escrow Buddy, which is one that also deals with File Vault and generating new keys without a user's password, and you can send the new recovery keys to your MDM server. And Jamf Connect, aka Nomad, and Xcreds also use an authorization plugin in some form or fashion here. I'm not going to go too deep into it. There is a great talk by Tom Bergen and Jeremy Baker from PSU many, many moons ago. Give it a watch. I think the audio cuts out like 3/4 of the way in, and it's kind of sad, but like you get a good gist of it. Okay, so we got the plan. We're going to capture the password with the authorization plugin. We're going to use that to update the ACLs, and then we're going to get a beer, because easy peasy. Like, I mean, how hard could it be, right? Turns out, very. Especially if you don't know anything about the Keychain APIs. It is very fun, and my immediate reaction when I went to start doing it was, I just want to cry. Still a very common topic in therapy right now, but apparently this is supposed to really help with that anxiety. Okay, so that's great. You had this problem. What actually happened? Did you actually manage to do it? And the answer is yes. So we did write the authorization plugin, but we had a problem. Remember how I mentioned that the keys were encrypted on disk? So the password to that encryption was also in the keychain. And I didn't have access to read the password from the keychain either. So that was a bit of a problem. But what I did manage to do was I was able to update the ACLs for the password. I was able to read the password. Like, I gave myself access to the password, and then I was able to use that to decrypt the key on disk and then re-import the keys that were on disk, like deleted the ones from the keychain and then completely re-imported them so we could have full ownership. There's a couple of gotchas along the way, which we'll cover towards the end, like I mentioned earlier. But we managed to do all of that, set all the ACLs that we wanted, and then at the very end, we removed all the keys from disk, and security was very, very happy. So that's like a quick synopsis of like how in the world like we did that. I didn't want to like take too much time because, you know, as it could be exciting on like what happens, I thought it would be best use of time if we actually like kind of explained a little bit about the keychain, even though that's like a like snore fest. But we'll try and make it interesting. Let's dive into the actual keychain. Who's like tried to programmatically interact with the keychain in some capacity? How many people thought it was nice and it was great and it was fun to use? Yeah. Yeah, of course, Mike. Thanks. Yeah. That sounds about right. About halfway through this, I kind of felt the same way. I was like, oh man, waking up every single day and thinking about the same exact thing for like 48 hours and then finally figuring it out, it's actually somewhat nice. Very, very rewarding. As you probably know, the keychain holds many things, and they have various types. You can put many passwords in there. There's generic ones. There's like internet passwords. You can put your private keys in there. You can put your public keys. You can toss some identities. And then, of course, put some certificates in there. So keychain items have what we call attributes. And it's kind of the same as like attributes about people. It's like, oh, you're nice, or you have like red hair, or your feet are size 14. You know, like all attributes about yourself. Keychain items also have those as well, and they have a lot. There's a lot of different attributes that you can do on a keychain item. So many. Most of them you probably don't need to worry about, but hey, everybody gets an attribute. But there's one attribute about keychain items that I did want to cover today, and that was about a little attribute called KSEC adder access. And what that is the value for this attribute is what is called a sec access instance, and that sec access instance describes all of the access control settings for that particular item. And one note about this particular attribute, you can use attributes to search the keychain. You can't use this one to search the keychain and say, oh, give me all of the items that I have access to, like this app has access to. You can't just do a default query like that. You'd have to basically query the entire keychain and then iterate through it all. Okay, so we know about access and the items. Which items of these actually have this like sec access attribute? Internet passwords, generic passwords do, and private keys do as well. Public keys don't, because well, they're public, and you can't control anything about it. Same with certificates. Like it's pretty much free for anybody to use and have fun with. And then inside of those sec access instances, and this is we're getting deep. Just bear with me. We're getting there. Inside of the sec access is sec ACLs. I know. Just hold on. Bear with me. And then so you can define many sec ACLs in an access instance. Very confusing. So to help make it a little bit better, and these are some of the attributes that you can have for sec ACLs. There's 4 of them. We'll go into a little bit deeper later, but just to help alleviate how deep we've gone. Okay, so we're at the top. We're at the keychain, right? We have a private key. So the private key is in the keychain. The private key has attributes, one of which is a KSEC adder access. It also has a label, so you actually know what the name of it basically. And then an additional attribute is like, is it extractable? Can you take the key out of the keychain? Or is it stuck in there and you can't do anything with it? So we mentioned that there's the sec access, which is the value for the attribute name, the attribute key. And then the label attribute is very simple. It's just a string. Nice little name. You can name it whatever you want. My fun keychain. Item, literally have your way with it. And then the adder is extractable is a Boolean. And in this case, we don't want to be able to extract it. So onto the sec ACLs. So the sec ACLs are inside of the sec access instance. And you can have multiple, right? Who's lost? Who's like, sweet mercy, I want nothing to do with the keychain anymore. Yeah, I still feel that way. Yeah. And then your sec ACL has properties of like description, apps, and different authorizations. And I was working on this slide yesterday, and I was sitting next to Nate. And Nate immediately went, "Oh my God, ooh, David." And I was like, that best describes this situation. Anywho, back to the delightful sec ACLs. So as I mentioned, there's various properties to a sec ACL. One of them is the description, and it's not just like, oh, my cool like sec ACL description. That's not what it's meant for. It's actually meant to be the description whenever an item tries to access it that doesn't have access to it, and that's what the prompt uses to display to users. So which in this case, whenever PKG build decides it wants access to this developer ID installer key, that's the description on the key, and that's what gets displayed to the end user. So if you're like building like identities and you're chucking them in the keychain, one of the things that you can do is you can actually use this as a mechanism to be very descriptive about what the actual private key is, just in case something decides it wants access to it, and you want to like kind of guide folks on whether or not they should actually type their password in here and hit like allow all. So for us, when we like generated the new keys, I actually made the description of this talk to the help desk. Like it's the internal identity. If you have questions, go talk to the help desk. Obviously, it's not that big. It was significantly shorter, but you get the idea. Okay. And this is one everyone's probably familiar with, is when applications have access to an item. And so this describes like all the applications that'll have access. And this is probably what everyone's used to, as you can see here. You can add and remove them very easily in the GUI. This is what I was going after when we initially were started down this project. This is always an array. And if the array is empty, if there's nothing in your app array, then nothing has access to it. I don't know why you would do that. I guess if you just chucked it in there for lulz and you didn't want anything to use it, you could go ahead and do that. Or if you define the array as nil, then everything has access to it, which would be the same as checking the allow all applications access to this item at the top. And the one that was completely new to me was what's called a prompt selector. So the prompt selector in a sec ACL is what's used to describe the interaction that you get whenever you try and access it. So for instance, even if you have the ability to access the item, you can say, even if you have access to it, prompt the user anyway. I want the password for it. And that's what this little guy there does. And then last but not least, for sec ACL is authorizations. So an authorization describes the operations that the key is actually allowed to do. And you can see that here in the GUI. This particular key is allowed to decrypt things, it's allowed to sign things, and it's allowed to unwrap things. I did not look in to see what unwrap actually does. We can sort that out later if you actually have a question about that. I don't know. But here are all the possible authorizations that a key can have. And you're like, oh, that's quite a few. That is true. There is several there. You'll probably only really be interested in these, which is going to be any, sign, encrypt, and change. Any basically means that if you set this authorization, it can do anything. It's kind of like God mode for the key. It can do all of the authorizations that you want it to do, which is not great. You know, normally you want to be a little bit more specific. And that's why most folks go with like, oh, you can sign or you can encrypt with these particular keys. And then change ACL is fun. So that's an authorization on the key that says this app is allowed to change all of the other authorizations in the key. So that gives you like good control. So if you actually create the identity, you want your app to be in the change ACL list, so then you can easily modify everything else without disrupting the user with a prompt of any capacity. And then there are two more, which are the integrity and partition ID authorizations. And does anybody want to start a drinking game any single time I say authorization? Does that sound fun? That would be great. We'd all be drunk by now. All right, so partition ID and integrity are two that you will also see. And those are fun because those are actually only available in the default /login keychain or a custom keychain. So if you go into keychain and you're like, oh, I want to create a new keychain to like mess around with, it will also have these attributes, or these authorizations. And then there is one on the list here that is not for you at all. This is strictly for internal use only, and that is the change owner one, which it does sound very familiar to the change ACL, but they are in fact different. Change owner, don't go there, stay away. Don't do it. Okay, so everyone's asleep. Awesome. Pop quiz time. Who was paying attention? Everybody? Yes, love it. Fun. Okay, so here is a dump of a keychain ACL. Given what I just told you about descriptions, authorizations, prompt selectors, what's weird here? Anybody? It's like, I mean, it is like 11:20. It should have started an hour ago. Anybody? No? Yep. So that is not a human readable description. It's supposed to be. It's not. What the heck does that mean? Oh, that's not a description either. What the heck is that? So the top one, I'm pretty sure is SHA-256. I'm not sure. It's the right length. The bottom one here is really interesting. What's that look like? Not you, Frogger. Anybody? Oh, okay. Maybe you've done this before. No? So that is actually a hex-encoded plist string. Very descriptive. So for that, which is the partition ID, this was introduced in El Capitan. Like I said, it's only on the login or custom keychains. The application array that was in there, if you probably missed it, it's always nil. Everything can always use it. And the description is a hex-encoded plist string. The inside of that hex-encoded plist string is an array of certificate team IDs. So whatever the developer signing team ID is, it needs to be in this array in order for the item to have access to it. It's a additional layer of security that just makes interacting with the keychain oh so more entertaining. And the really fun piece about it is even if you own the app, if I took a key, put it in the keychain, I own it, it's mine. Go away, it's mine. Apple still won't let you change this without the user's password in some capacity. It is just an additional layer of security. But like I said, we won't get into how much beer was consumed over this one. And then, like we mentioned, the integrity key that was also there. They're kind of linked together. They were added at the same time. And as I mentioned, it appears to be a SHA-256 of some kind. If somebody wants to play around with it and actually figure out what in the world it does a little bit later, would love to pair and have some fun with it. But yeah, it has the same general attributes as the partition ID. So what does that actually look like then once you decode it? That's what it looks like. So the key is partitions, and then the value is an array of team IDs. Some of those are real, some of those aren't. I'm assuming you can guess which one isn't real. Might be there at the end. Yeah. Yes, yeah. Actually, I'm pretty sure it is, yeah. And one of those might be Stripe. Anywho, and you're like, wow, that doesn't look like a Team ID. It just says Apple, and it's got a little colon on it. Basically what that means is anything that's signed by Apple can also use this, to simplify it. Cool. So, that's the partition ID in a nutshell. All right, now on to the fun part. So, I thought, you know what, it might be useful to show y'all how to actually write some Swift code that can update the ACLs on an item. And I was like throwing the slides together, and I was like, I am putting myself to sleep just looking at this. So I was like, let's not do that. That sounds extremely boring. Instead, let's watch somebody up on stage try and run code live and interact with a keychain. What's more exciting than that? So, all right, let's give it a whirl. So, let me do this. Just prepping the keychain real quick. How's everybody's day? Great. Everyone's having fun. Does anybody want to tell it? Oh, actually, was anybody here in 2019? I'm here. Does anybody remember a talk Graham and I gave together about crypt? I noticed. So no one's here has done a shared talk this year. But when Graham and I were up here, Graham went first, and I was also up on the stage. So I was just like, I think I was standing here. And I was like, that doesn't feel like the right place to stand whenever somebody else is giving the talk. And I was like, literally had no idea where to actually stand. And it was very amusing. Instead, you just stand over here and duck behind the desk. All right, let's go. Cool. So we have. Oh, I covered the other one. Oh, okay. Cool. Sweet. All right. So as you can see, we've got some identities in the keychain, and this particular app, or the ACL here, just has Safari in it. To prove that we have not done anything pre-recorded ahead of time, because that would be way too safe and way too boring, who wants to suggest an application that we can just chuck right in there? Anything? I mean, any ideas? Chrome? Something fun I might have? Yeah. Something with Electron? Ooh. What I got? Slack? Yeah. Yeah. We got Slack, right? We got Slack. Okay. Actually, I should have not. Typing's hard. Why is the lag here? Okay. Slack. Probably. And then, what's another one? Do I have Spotify? Is Spotify Electron? Or did I delete that malware? I do. Oh yeah, sure. Oh, that's Visual Studio Code, right? Yeah, Visual Studio Code. And then, did I hear 1Password? Definitely got that. I can't see behind me, so that's fun. Applications, 1Password. And you remember how we were talking about Touch ID for sudo? Got you. Okay. Now let's do. So I wrote a little tool called KeyCTL, and then we'll say we want to do the endpoint sudo. Cool. once it put itself in there, but I couldn't figure it out. All right. Error creating static code object. See, this is a terrible idea. Maybe I set this up for the lulz to have fun. It's true. Let's close this, open it back up, because doing live modifications not so great. And gonna stripe. That's not how you spell stripe, or put a dot. And no, definitely didn't work. Cool. Failed demo. That was, what in the world? Yeah. I swear it does work. Which is what everybody says, right? Let me double check here. Where is, I want to do displays so I can actually like read this. Man, how much time do I have? No? Good. Oh, all of that stuff's hard-coded. That bit's hard-coded, yeah. But that might actually be, yes. Which is, because I was tweaking with it last night. Did not find out application. Oh, maybe that's. Let's go back and do. Setting info. That's fun. Maybe I broke that at some point this morning. Great. And once again, that's why you don't do live demos. Anywho, back to it. Maybe I'll fix that and do a little quick talk later. Cool. What did we learn? Don't do live demos. So there's an attribute called ksec_adder extractable, which I hinted on is used to say whether or not you can pull, once you put the key in, can you pull it out? And if you try and pull it out when this is set to false, this is the little prompt you get. Some things about it, things I learned the hard way. Once an item's in the keychain and you set this attribute, you can't change it, even if you want to. I'm assuming it has to do with how it stores it in the keychain once it's put in. Assuming one goes this way and one goes this way, and then once you're past that Y, you can't go back. Which is why I had to end up deleting the items and re-importing. Because one of the requirements we had was we wanted to make it so you couldn't export it from the keychain. And you literally can't do that once it's in there. If you use the API secItemAdd to add an item and you specify this attribute, doesn't work. Got a bug open. You have to use a deprecated API, because that's where all the good stuff works, in secItem import. And it's very, very confusing to specify all that in the deprecated versions. They're just way harder to interact with. And what you need to do is in the key parameters, you need to exclude this from the attributes list. And if it's not there, it basically means you can't take it out. It's like falsy, which is my favorite word that I think Greg termed. Falsy, anywho. Lovely notes about the partition ID. When you generate an access instance, you create it and it gives you a default template basically, and it doesn't include this in it. This authorization only gets generated whenever you plug it, as soon as you import it or create it. And like as I mentioned, you can't modify it even if you own the app whatsoever. You need to modify it with set keychain items, set access with password. And last but not least, set trusted applications. So all the applications that are sitting in that like window that you can like add and remove and that I failed to do programmatically, those are all sec trusted application instances. And whenever you add them, it's like a snapshot for the app at that time. So if at any point you're like, okay, here's the path to like VS Code or something in the keychain. If VS Code changes their signing info, the keychain will notice that, and it'll be like, I don't care that your app is at that path that you specified. Historically, it had this signing info whenever you specified it. So if you change it, it's no go. You're gonna have to re-add it. But the worst part is you don't know what the signing info was when it was added. So you literally have no idea. I actually started tracking what the signing info is whenever we add things. I like track it on the side so I can like do a check and then pull it and replace it if the app ever gets updated. It's very gross. But yeah, oh, I got a little ahead of myself there. Fun. And I will say that this particular tool, do any of the folks that used to work at Dropbox, do you even know about this? No? It's amazing. Somebody wrote it, published it like 6 years ago, and I would not have even remotely been able to do any of this if it wasn't for the code sitting in this repo. It's fantastic. I probably won't publish any code that we've actually written because lawyers. But please have a look at this if you are interested in like setting ACLs, syncing them. You can. This was basically invented if you have, because most things can't use the keychain. And you'll probably have some items that use the keychain and some that can't. And if you run this, it'll basically put the two together. So if like you modify it on the disk, it'll just like slurp it into the keychain and like replace it for you. It's quite fantastic. Okay. Q&A. One warning. Every question is a beer later. Or we're not doing QA. We're done.
We're not doing QA. That's QA.
By the way, I'm hiring.
Oh, definitely tell people.
Yeah. And thank you.